Is it good for you?
Yes, perfect. Thank you.
Thank you, Tatiana. I would like to present today the use of machine learning methods in the geotechnics, especially in the prediction of dynamic soil parameters and behaviors. And I will, especially on the topic of the presentation will be the choice of and the impact of the choice of databases in this prediction. The work the presented work today is the result of a collaborative work done by Julien Borderon, Julie Régnier, and I from CEREMA, which is a French public institute. So my presentation will be divided in 6 points. First, the introduction, then the presentation of the 3 initial databases, and the data preparation step, and then the details about the method, some results that will be discussed together, and finally the conclusion. So first, the geotechnical engineering frequently contends with significant data challenges. As highlighted by recent study, the field of geotechnics is by history a data poor field with only few data sets available. And now we have a slow transition to a so-called data-centric geotechnics. Meanwhile, researchers and engineers are working now to better understand, for example, the divergence in their measurements which, in laboratory, which lead to develop new methods for harmonizing data collection. And for example, here today, we are focused on the measurement and on the shear modulus and damping ratio curves at very low distortion. Now, in geotechnics, it is common to encounter data heterogeneity when databases are created for diverse purposes and collected across different regions about different soils, type of soil, and adding complexity to the development of accurate and generalizable predictive models. So it's become harmonizing geotechnical dataset becomes very essential now for reliable model development. This involves extensive data preprocessing steps, including outlier management, normalization, and data selection. However, even with this adjustment, selecting appropriate databases remain a significant challenge. So now I will introduce to you a novel approach in geotechnical engineering using Shapley values methodology, which is originally developed within cooperative game theory to quantify the individual contribution of each database to the performance of a machine learning model predicting the nonlinear soil behavior, for example, now, today. And this novel approach will objectively evaluate the impact of each database on shear modulus curves, or the famous shear modulus curve, or the damping ratio curves, facilitating a more strategic selection of data sources. So first, we go back to the initial databases. We have 3 Italian geotechnical databases with a collection of, for example, shear modulus reduction curve and also damping curves, which have been recently published. We have the Italian geotechnical database of Facciuoso team, Ciancemino team, and Gauduzio team. And these databases were built using data from different sources from lab tests of University of Florence for the first one, from lab tests to the Institute Politecnico of Torino and University of Roma, and for the third one, with multiple lab tests dedicated to seismic micronization studies. The first Factuoso database contains 170 undisturbed specimen, and the answer of this specimen of clayey soil tested with resonant shear test and cyclic torsional shear test. The second one, Chantimino databases, contains 181 undisturbed soil specimen, which are clayers and silty soils, tested with resonant shear test and also cyclic double specimen direct sample shear test. And the third one, Gauduso database, also contains 181 undisturbed soil specimen, clay and silty soils, tested with resonant shear test and cyclic double specimen direct sample shear test. You can see at the bottom of the slide the distribution of the different measured shear modulus for the three databases, and each point here, yellow point, is correspond to a measure in lab. In addition to the shear modulus reduction and damping ratio curve, the databases, the three databases, provide soil physical parameters and condition of lab tests. For example, you can see in the table the plasticity limit of the soil specimen, or the initial void ratio, water content, which are very useful to understand the dynamic behavior of soil. And some of these parameters are only available for few tests, such as the density of the grains or the over-consolidation ratio. So in this work, we only consider parameters well represented in the three databases and common at least to two databases. Then you have the data preparation with several steps of data cleaning. And finally, the dataset contains 6,635 rows. And you check the distribution of each feature. For example, here you have the distribution of the confining pressure of the lab test, or the plasticity index of the soil specimen, and you see the overlap of the three databases concerning this feature. The method used, the original method used is the use of Shapley values to quantify the individual contribution of each database to the performance of a machine learning model predicting the nonlinear soil behavior. You see here in the slide the formula, mathematical formula of this approach. And in our case, each player is a database, and the payoff is a metric of our model, that is to say, the R square. And by evaluating the marginal contribution of each database across all potential combinations, this metric allows us to find the best combination to measure how interactions between databases influence the models, and to see if there is a type of database more useful. And also to predict for example, the shear modulus curve. We try several models and find the algorithm called XGBoost regressor was the best one, in agreement with recently published paper. So here are the results. You see in the table the Shapley value for each database, Chantimino, Factuoso, and Gauduso database. So the model was trained on the merge of the three databases, and you see for the first two lines that the Chantimino and Factuoso have nearly equal Shapley values, which suggests to us that both databases have a strong and similar level of contribution to the model's predictive performance. And for the final, the third line, we see the Gaudiusi Shapley values, and which the Gaudiusi database has slightly lower predictive contribution, which is due to, for example, the difference in data quality or specificity of these databases. So to conclude, we can say that this presentation show a new way of using Shapley values in geotechnical engineering as a tool for evaluating and optimizing the contribution of different databases in predictive modeling. By quantifying each database impact, we can make decisions about which datasets are most valuable for specific model parameters, such as shear modulus and damping ratio curve. The findings suggest that database quality and data origin significantly affect model success, and that a tailored selection process can markedly enhance model performance. And it is a promising framework for the future, especially as more geotechnical data become available. And by applying Shapley values method, researcher and engineer can better navigate the dataset heterogeneity, ensuring that the most suitable data sources are available to improve predictive outcomes. So thank you for your intentions. We would like also thanks the Institut Carnot ClimatAdapt with the media project for the financial support of this research.
Thank you very much. So there is a question in the chat saying, did you use any specific library such as SHAP, or did you use your own implementations?
Shapley values.
For the Shapley values.
We use the Python library to do that. So it's not we developed the method with Python tools.
So it's your own implementation. Okay, thank you. So let's thank you for that presentation. We will now move on to the next one. Let me introduce Dr. George Erhater from the Norwegian Geotechnical Institute, Norway. He will explore machine learning applications in tunneling. So Dr. Erhater, please